Nathan has a bag that contains only red sweets and green sweets. He takes at random 2 sweets from the bag. The probability that Nathan takes the same coloured sweets from the bag is 13 out of 28. Originally, there were 5 red sweets in the bag. Work out how many green sweets there were originally in the bag. This is quite a difficult problem, and in order to do it, I'm going to use a tree diagram. I'm going to assume originally, just so we can work out what the algebra should be, that I had 8 sweets altogether, and therefore 5 of them are red, which means that 3 out of 8 will be green. If we take one red one out, this becomes 4 out of 7, because there's only 7 left, and this will be 3 out of 7. And then if I take a red sweet here, it'll still be 5 out of 7, and the green one will be 2 out of 7. But these are fractions, and I've just assumed there are 8 in there. I don't know how many there are, and I don't know how many green ones there are. So I'm going to now look at this algebraically. If I know I have 5 red sweets, that's going to be 5 out of n. Then down here, I'm going to have n minus 5 over n. Okay, look, to get the 3, I do 8 minus 5, and I get 3, and the 8 is n. Right, having taken one here, this now becomes 4 out of n minus 1, but I still have n minus 5 green ones here out of n minus 1. Over here, I have 5 over n minus 1 sweets. And then here, I've now taken another one, so it'll become n minus 6 over n minus 1. So I just made this up in order to help me come up with these expressions, which is a valid examination technique. So let's just get rid of those, and we're now left with the algebra. We know to get any arm on the probability tree, we need to multiply. So we want the probability the same colour, and we know that to be 13 out of 28 from the question. So we know that this times this will be 5 over n times 4 over n minus 1, plus n minus 5 over n times n minus 6 times n minus 1 will have to be equal to 13 over 28. So this is my equation. So it's now just an algebraic problem which needs to be solved. The common denominator is going to be n times n minus 1. And then I need to do 5 times 4, which gives me 20. And then I'm going to have to multiply n squared. If we expand this, n squared minus 6n minus 5n, which makes minus 11n. And then plus 30. And that's equal to 13 over 28. And that will become n squared minus 11, and then we add 30 and 20 together, we're going to get 50. In the denominator, we're going to get n squared minus n, and that's still equal to 13 over 28. So let's just write that out again. Right, what we do now is we cross multiply. So we're going to get 28n squared minus 11n plus 50 is equal to 30 times n squared minus n. So we're going to get, expanding the bracket, 28n squared minus 308n plus 1,400 is equal to 13n squared minus 13n. That becomes 15, when we take this over here, 15n squared minus 295n plus 1,400 is equal to 0. These are all at least divisible by 5. So dividing by 5, we get 3n squared minus 59n plus 280 is equal to 0. Now, because we know n must be an integer, this does actually factorize. So you can actually do the product, but it's going to lead to big numbers. 3 times 280, which is 840. The sum is minus 59. We want two numbers. When we multiply them together, we get 840. And the same sum will give you minus 59. With a bit of trial and improvement, you will come up with minus 35 and minus 24. If you add those together, you get that. And if you multiply them, you'll get positive 840. So you write down the quadratic equation. So it's 3n squared minus 35n minus 24n plus 280 is equal to 0. Group the first two terms together, common factor of 3n. No, sorry, it's a common factor of just n, not 3n. And then we're going to be left with 3n minus 35. Bring down that minus sign, group the next two together, take out the common factor of 8, and we're going to get 3n minus 35. If you do this process here and here, you're going to get the same bracket. This now comes out as a common factor, so you get 3n minus 35, n minus 8 is equal to 0. So we either 3n minus 35 is 0, which means that n is 35 over 3. Now that's not possible because n has to be an integer. It represented the number of balls in the bag, so not possible. Or n minus 8 is equal to 0, n is equal to 8. Now, it might have been better or easier, particularly in an exam, to solve this using the quadratic formula because the numbers are quite large. So using n will be minus b plus or minus b squared minus 4ac over 2a. You should really learn this, but it is actually printed in the front of any exam. Putting the numbers in, we're going to get minus 59. Be careful with the minus signs. Plus minus 59 squared. Now, people don't usually put this in brackets, and therefore, when they square it on their calculator, they get a negative answer. When you square a negative number, it becomes positive. Minus 4 times a, which is 3, times 280, all over 2 times 3. And that's going to give 59 plus or minus the square root 121 over 6. We knew that this is going to give an integer value because this gives you 11, square root of 121. So that gives that n is 35 over 5, or n is 8. This one not possible, and this one is possible. We found the total number of balls in the bag, but we haven't actually found the number of green balls, which is what the question asked for. Okay, so we go back to this. Okay, we know that n is 8, so we put in the numbers 5 over 8, 3 over 8, 4 over 7, 3 over 7, 5 over 7, 2 over 7. You get these numbers by making n equal to 8. We're interested in this one, the number of green balls in the bag originally, which was 3. Okay, and the number of green balls is going to be this one, which is 3. So there were 8 balls altogether, but 3 of them were green. Okay, so this has been a video to show you how to do a probability question, sort of in reverse, which is getting quite common these days. I hope you've understood, and I thank you very much for watching.